Hey everyone! So today's programming project is an attitude indicator written in Rust. Unlike what the name of this project might lead you to believe, this is not an indicator of overall sassiness, but rather part of the instrument panel in most aircraft. It basically helps determine spatial orientation. You have pitch, which shows you where the nose of the aircraft is pointing vertically, and you have roll, which shows you how tilted side to side you are. I do want to point out though that I am not a pilot, but I did think this would be a super interesting thing to create a UI for. There's a Rust library for building GUIs called egui, and it has not let me down yet, so I decided to go with it again for this project. Disclaimer though, I previously coded this in Java a long time ago, but I'm really into Rust now and had to find a way to convert the original Java implementation into Rust, hence egui. Also, second disclaimer, this project was AI assisted, but I am a firm believer in being able to actually explain your code and pick it apart rather than blindly generating it. So here we go. The whole project ended up being rather small, just under 330 lines of code, so I didn't do any elaborate sectioning out of the components and was completely okay with dumping everything in main RS. I feel like if I had ended up doing the entire instrument panel, this project would have a much more sophisticated structure, but this was fine for me to just get the basic concept working. The first part was creating an E-frame of 500 by 600 pixels and aligning the components within it. The main display has the orientation of the aircraft, while below it are two sliders, one for adjusting the pitch and another one for adjusting the roll. Both of those values are stored as 32-bit floats. Then I added a reset button so that you can return the aircraft to level flight. Just in case you ended upside down or something. I wanted to make this digital version of the indicator look very close to the real deal, so I selected sky and ground colors that I've seen in many pictures of real attitude indicators. There's also a pitch ladder, which are these horizontal bars showing you what the pitch angle is in degrees. For the roll, there's a triangle indicator at the top, along with a bezel circle to help follow this value. And instead of rotating an aircraft model itself, I'm actually rotating the entire background. So this means that the sky, the ground, the horizon line, and the pitch ladder are all drawn relative to the center and rotated based on the roll angle. Turns out, this moving of the background is how real attitude indicators behave, so it felt good to have that be true to life rather than being some hacky workaround. So first, I converted roll into radians because all the trig functions expect that. And then for pitch, I mapped degrees into a vertical pixel offset of about 4 pixels per degree. So increasing pitch just shifts everything up or down. To draw the background, I created two large rectangles, one for the sky and one for the ground. They're intentionally oversized so that when they're rotated, they still fully cover the circular viewport. Each rectangle gets rotated using a helper function that applies this standard 2D rotation transform around the origin, and then everything is translated back into screen space. On top of that, I drew a horizon line, which is just a rotated line segment at the pitch offset, and then the pitch ladder. The pitch ladder is generated using a loop every 10 degrees, with longer lines every 30 degrees, and text labels on both sides. For roll, I draw a circular bezel and then place tick marks every 30 degrees, using sine and cosine to position them around the circumference. The labels are adjusted so that values above 180 wrap into negative angles, which matches how real indicators display roll. The aircraft symbol itself is completely static. It's just a couple of line segments and a circle drawn at the center. Because everything else is moving relative to it, it just gives the illusion that the aircraft is rotating. So yeah, I'd say that the indicator ended up looking pretty close to the real thing. I'm always down for feedback though, so if you want to dig into the code, feel free to check out the GitHub link in the description below. Until next time, bye!